COSMIC is a constellation of satellites that orbit the Earth and provide measurements of temperature, pressure, and moisture in the atmosphere. These measurements are important, and it helps weather forecasting because it gives us an understanding of what the atmosphere is doing at different levels in the atmosphere.
The COSMIC-1 program, which was 6 satellites launched in 2006, was sponsored by a number of agencies. The National Science Foundation, NOAA, and UCAR actually carried out the program with the sponsorship of these agencies and with the cooperation of the National Space Program Office in Taiwan.
3, 2, 1, and 0, and liftoff.
With the advent of new space technology and the ability to launch larger amounts of mass into orbit, we're able to put multiple satellites into separate orbits, and this is very beneficial for the COSMIC-2 program.
With the COSMIC-2 FORMOSAT-7 mission, NOAA is leveraging the large, significant investment that the National Space Organization in Taiwan has made to procure the spacecraft, as well as operate the command and control facilities.
The implementation of FORMOSAT-7 has promoted substantial scientific and technological cooperation and diplomacy between Taiwan and the United States. Taiwan team is responsible for joint program management, mission system, design of spacecraft bus, satellite integration, mission operations, satellite operation, and the control centers.
COSMIC-2 is very exciting because now we're going to have measurements around the equator, especially in areas where there is a lot of hurricanes.
To forecast our weather 3 days or 5 days or 7 days out, we need to know about the weather that's forming upstream from us. That might be as far away as Africa to the east, where the tropical depressions that grow into hurricanes form.
For hurricane prediction, the most important element is the moisture and its variation. 90% of weather is associated with the moisture in the air. Rainfall, clouds, hail, snow, they all are related to the change of the moisture.
The Air Force partnered with NOAA to provide the sensory suite for COSMIC-2. That includes all the sensors, so we have 3 sensors on each spacecraft.
The signals from navigation satellites can actually be used to take measurements of the state of the atmosphere.
The primary payload and the primary sensor is TGRS, which is Tri-Global Navigation Receiver System, essentially. And what TGRS does is it basically measures the changes in radio signals, GPS signals, as they propagate through the Earth's atmosphere. GNSS is the term used for all global navigation satellite systems. So essentially, US GPS is an example of that.
The signals from these satellites pass through the atmosphere, and when they do that, they bend and slow down just a little bit.
So the bending of the radio waves follows the same principle as the bending of a laser beam that passes from the air into a glass of water.
So at the moment when it bends through the atmosphere, this science can retrieve very important measurements for weather. So therefore it gives a very nice uniform measurement of the whole globe.
It's going to provide a wealth of measurements that we can use for our numerical weather prediction models. It'll provide more than 6,000 measurements with higher accuracy than any other method that we have.
Numerical weather prediction is a system we use to forecast the weather. And this system includes instruments that measure the weather and the temperature. It includes a numerical weather model, and it includes very big computers to process all of these data and produce forecasts. The more accurate data you have going into your system, the more accurate your forecast will be coming out.
Radio occultation data are important for climate studies because we now have a record that spans more than 20 years from COSMIC, and having this accurate data set helps us study the changing climate of the Earth.
Space weather impacts systems that we use on the Earth, like our cellular communication systems, our navigation systems, and even our aircraft.
The IVM and RFB are both secondary sensors. What they do is they provide measurements for electric field and electronic content in the ionosphere.
Space weather happens above the clouds, and instead of clouds that we can see, we have areas of charged particles in the ionosphere. And knowing the geographic regions where the ionosphere is active helps us understand how it's going to affect communication systems that we use here on Earth.
I'm excited about the new capabilities that the sensor suite will provide in terms of space weather. This is cutting-edge data that will be flowing into our military data centers as well as NOAA's Space Weather Prediction Center.
We're excited for COSMIC-2 because it can help us to better anticipate and forecast ionospheric effects and their impact on communications and GPS signals.
Radio occultations have been shown to be of the top 5 most impactful types of inputs that you can put in numerical prediction models to reduce the forecast error.
The sensor suite is fulfilling a gap and providing a capability that we do not currently have in space weather and terrestrial weather.
COSMIC-2 will provide 10 times the number of measurements that previous systems provided. And these measurements will help us improve our weather forecasting in the future.